What's going on, TikTok? This is day one of my series answering viewer-specific code challenges. Okay, so do me a favor, comment down below a specific exam question that you would like to see me answer. Really try to stump the instructor here, or if you have a specific topic, just let me know, comment down below, and I will type it into ChatGPT like you see me doing in this video. Again, this is day one. This is my first viewer challenge, and this is from our specific viewer, Jay Joppa. He wanted a voltage drop question that you might see on your journeyman's or master's licensing exam. So here I go, typing it into ChatGPT. This is live. It's calculating the question for me right now, and I'm going to show you how to calculate the answer. Okay, here's my voltage drop calculation. It says a 120 volt single phase circuit supplies a continuous load of 24 amps located 180 feet one way from the panel. I'm going to write down all these details. So 120 volt single phase, 24 amps continuous, located 180 feet away from the panel. The conductors are copper, THHN, installed in conduit, and the circuit is considered a continuous load again, and it's telling me apply 125%, which is interesting. Assume resistance for 10 gauge copper, which is 1.24 ohms per 1,000 feet, and 8 gauge copper. Wow, what? It's giving me two sizes? Assume resistance for 10 gauge copper, 1.24 ohms per 1,000 feet, and then 8 gauge copper, 0.778 ohms per 1,000 feet. And then it's saying loop. This is a voltage drop calculation. Calculate the voltage drop using 10 gauge copper conductors is question one. Okay, I'm going to scroll down so you can see what I'm seeing. Okay, this is not a typical voltage drop question that you're going to see on your licensing exam, but we're going to do what ChatGPT is telling me to do. So step one, it's saying calculate voltage drop using the 10 gauge copper, okay, which is the copper I wrote down. Let me write number 10. It gave me 8 for a reason, so I'm going to write down 0.778, and that's for my number 8. 2, determine the percentage voltage drop. Does this meet the recommended NEC guideline of 3% max voltage drop on branch circuits? If it does not meet the requirement, determine the minimum conductor size for 10 or 8 that will comply. Okay, I see what they're doing here. Now that's why they gave us the 8. Okay, so I'm gonna try to do this in order. I'm gonna open up my camera so you can see what I've got going on here. I'm hopefully gonna put the question on the screen so that you can still see it. So question 1 says calculate the voltage drop using the 10 gauge. Okay, so what we need to do first is write down our voltage drop formula. So I'm going to write down voltage drop equals 2 ril over 1,000. Okay, now there's two voltage drop formulas, right? It's the 2 ril over 1,000 or the 2 kil over the circular mils. The reason why I'm using the 2 ril is because it gave us the resistance per 1,000 feet. So that's what this is, resistance per 1,000 feet. The other thing that we need to recognize in this question is that it said single phase, okay? If the question ever specified 3 phase, it's the same formula, but instead of doing 2, we would do 1.732. Now that we have our formula, we're gonna start plugging in what we know. So I'm gonna write down voltage drop equals 2 times our resistance, which is 1.24 ohms per 1,000 feet, again, which is specific to our 10 gauge copper, which is what this question is telling us to use here, times our ampacity. Now, this is a trick question. It tells us 24 amps continuous. I'm going to write down 24. There might be some people that's going to say, well, it says continuous, you need to apply 125%, okay? Which would be 1.25 equals 30 amps. So some of you might be writing 30 amps here, but I'm just going to open up my code book because I want to show you something. I believe it's 210. I can't believe I turned directly to the page. 210.19A1, okay? This is how we size branch circuit conductors as well as the overcurrent protective device, okay? Branch circuit conductor shall have an ampacity not less than the larger of the following. Where a branch circuit supplies continuous loads or any combination, the minimum branch circuit conductor size shall have an ampacity not less than the non-continuous load plus 125% of the continuous load, okay? That's great, but remember, that's how we size the conductors. It already gave us the conductors, okay? So I don't think we need to do the 125% because we're not sizing the conductors right now. The question already did that. We are using the amperage given to us to calculate the voltage drop, not to calculate the branch circuit conductor sizes, okay? So I'm sticking with 24. Let's see if ChatGPT recognizes that. It might not, okay? And then the length, what did it say? 180 feet and then over 1,000. So there we go. We have our formulas filled in. Now I'm going to answer the numerator, which is the top number here. So 2 times 1.24 multiplied by 24 multiplied by 180 gives me 10,713.6 over 1,000 divide by 1,000 gives me 10.7136. Okay, so that's the total voltage dropped here. Okay, so I'm gonna round to the nearest hundredth. Okay, so 10.71 is what I'm gonna actually do because question 2 says determine that the percent voltage dropped. Okay, so the way we do this, the input voltage was 120 volts. Okay, so that's our electromotive force. That is the input voltage. So that's our 100% voltage. So I'm gonna use cross multiplication to figure out the percentage. Like what percent is 10.7 if 120 is our 100%. So I'm going to write down 10.71 volts equals what percent. So now we're going to cross multiply here. Okay, so I'm going to do 10.71 times 100. Everybody sees that that's what that circle is. I'm multiplying those together, and that's going to give me 1,071 volts equals this number, 120 multiplied by x. Okay, x is what we're solving for, so I'm going to use basic algebra to divide 120, cancels those things out, and it isolates my x. But what I do to one side of the equation, I have to do to the other side. So divide by 120 on the other side, dividing by 120 is going to give me the percentage. So 10.71 is 8.9% voltage drop. Okay, so question number 3, let's actually turn off my camera here. Question number 3 says, does this meet the recommended NEC guideline of 3%? No, it doesn't, right? That's over. 8.9% is over our 3% recommended. So now it says, if it does not meet the requirement, determine the minimum conductor size, 10 or 8, that will comply. Okay, so we just determined that 10 does not comply. So the question is, does 8 comply? Okay, so in order to do that, I might not have time to post this whole thing. I might have to split this video up. So now I'm going to write a new formula, right? So it's still the same formula here. 2 times, instead of using 1.24, I'm going to use the resistance of the 8, which is 0.778, times my I, which is 24, times my length. Like all that information stays the same over 1,000. So let's determine if that number is going to work. So 2 times 0.778 times 24 times 180 gives me that. I divide that by 1,000 and it gives me 6.72 volts. And the way I'm going to do this instead is it's saying let's not exceed 3%. So I'm going to go with 120 times 0.03, that's going to give me what 3% of 120 is 3.6. So I can't exceed 3.6. So even size number 8 doesn't work. So I'm actually going to have to go to number 6 and see if that works. I have a feeling that's not going to work. I might have to go to number 4. So ultimately, I think ChatGPT did something wrong here, but let's see. So let me scroll down. It does say if you want to push it further, okay, if you want, I can also walk you through the full solution step by step or give you 3. So let's do walk me through the solution step by step. Let's see what ChatGPT did to see if either I got it wrong or they got it wrong. We'll go through it exactly like you'd expect, okay? Volt is 120. Load is 24 amps continuous, okay? This is exactly what I did. Okay, step 1, apply 125% for continuous load. That's what it told me to do, okay? However, I think that that's a mistake on ChatGPT's part, okay? Step 2, determine the circuit length, 100 feet times, yeah, okay, we know this. 180 feet times 2 is 360. Oh, so it's ohms per 1,000 feet. Okay, they gave me a K, which is not, it's, what are you doing here, ChatGPT? 1.24. Okay, again, regardless, if you use the to kill formula over the to ril formula, the answers will be the same. So it's not like I did something wrong and they did something wrong. Round trip length, that's what the 2 is for. Step 5, voltage drop. So they got 10.7 volts. Wow. Okay, here's what I'm going to do. I'm going to type this into ChatGPT. Ready? Ready for this? You probably can't see it right now. Why did you calculate continuous load for the amps when article, what is it? 210.19A1 says to only use 125% when sizing the conductors or OCPD. Let's see what ChatGPT says here. Good catch, and you're reading the NEC correctly. Oh, thank you. I appreciate it. You're right. NEC 210.19. Okay, so why did I include 125%? Short answer, I mixed 2 exam layers that often get blended in practice questions, but they are technically separate calculations. Correct separation. Conductor ampacity. Okay, voltage drop calculation. Engineering check. Voltage drop is based on the actual load current, not the adjusted 125%. So for voltage drop, use 24 actual load. Okay, so now that I corrected ChatGPT, now it's going to give me what it thinks is the correct answer here. Okay, distance. Okay, and again, what it's doing incorrectly here is doing 180 multiplied by 2, which it does that in the equation, 2 ril over 1,000 feet. That's what the 2 is for, right? So why? Okay, it's getting 10.71. So it's still, oh no, it did. It got the correct answer now. Okay, voltage drop is 10.71. Okay, so it's getting the same exact answer I did. Can everybody see that? You probably can't. 10.71, okay? 10.71 is right there. So, percentage voltage drop is 8.93, right? Everybody can see that. 10.93 is over here, 10.93. Oop. No, 8.93%. There you go, 8.9. Key correction takeaway, 125% does not belong in voltage drop math. Voltage drop always uses the actual load current. Guys, guys, can you see how ChatGPT is not a reliable study tool for studying for your licensing exam? Can everybody see that? I just corrected ChatGPT for giving me incorrect information. It used a voltage drop formula that, don't get me wrong, would work, but the elements in the question were the resistance over 1,000 feet. Why would you use the to kill formula instead of the to ril formula? Again, regardless, it should get you the same answer, but they did something incorrect, applying the continuous load when Article 210.19A1 says we only use continuous load when we're sizing the conductors. The question wasn't asking to size the conductors. In fact, it gave us the conductor size. It's asking for the voltage drop. We do not apply 125% when applying or when trying to calculate the continuous load. Guys, this is a long recording, and I apologize for that. I'm probably going to have to split this into 2 videos, but I do want to give you the full description of how we calculated the voltage drop, which makes sense. When you look at it from point A to point B, exactly the way I wrote it, right, you're going to get the correct answer for your licensing exam. If you're using ChatGPT as your only study tool for your licensing exam, it is going to lead you down a road that's going to give you an incorrect answer, incorrect method to finding the answer, and that's just a shame. So do not use that. Use instead the content that we provide on this channel and my book, A Comprehensive Guide, where I teach you all about the voltage drop formulas, as well as so many other hot topics on the exam, so that you guys can pass your first time journeyman's or master's licensing exams. Hopefully this makes sense. Comment down below if you understood it. Give it a like, give it a share if you enjoyed the content. But again, guys, if you have other code questions or specific topics, comment down below so we can do day 2, day 3, and so on of this new series. Thanks for watching, guys. We'll see you on the next one.